Hello, 6th graders. Welcome to Big Ideas Math, 7th grade math, section 10.3, experimental and theoretical probability lesson. Pause while you write the lesson number and title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is students will compute the experimental probability of an event and the theoretical probability of an event. Copy the following key idea exactly as it appears into your notebook. Experimental probability. Experimental probability is probability that is based on repeated trials of an experiment. So the probability of an event equals the number of times the event occurs divided by the number of trials. Let's take a look at example 1, finding experimental probability. The bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? The bar graph shows 10 ones, 8 threes, and 11 fives. So an odd number was rolled 10 plus 8 plus 11, which equals 29 times in a total of 50 rolls. So the probability of the event equals the number of times the event actually occurred divided by the number of total trials. So the odd number was rolled 29 times, so that's a 29 on the top of our fraction divided by 50. Oh, my circle went a little crazy there. So the experimental probability is 29 over 50, which equals 58%. So it's called experimental probability because it's the probability that you calculate from doing an experiment. Example 2, making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? Find the experimental probability of a rainy day. So the probability of the event equals the number of times that event occurs divided by the total number of trials. So it actually rained 2 days out of the 12 days that we're looking at. So 2 out of 12 equals 1/6. So to make a prediction, we would multiply the probability of a rainy day by the total number of days in April. There are 30 days in April, so 1/6 times 30 equals 5. So we can predict that there will be 5 rainy days in April. So that is a prediction based on an experimental probability. Copy this key idea down into your notebook exactly as it appears. Theoretical probability. When all possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So write this in your notebook the way it's written. The P of an event equals the number of favorable outcomes divided by the number of possible outcomes. Example number 3, finding a theoretical probability. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So there are 3 vowels out of 7 letters. So the probability of choosing a vowel is 3 divided by 7. So that is about 43%. So experimental probability is when you get probability based on an experiment that you actually did. Theoretical probability is when you get probability based on a theory. So all of these events are equally likely. So if we reached into a bag and pulled out a letter, it's equally likely that we would pull out any one of these blocks. So in theory, this would be our probability. That doesn't necessarily mean that that's exactly what would happen in real life. Using a theoretical probability. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel? So the probability of a bobblehead equals the number of bobblehead sections divided by the total number of sections. So it tells us that the probability is 1/6, so we're going to put that on the left, equals 3, because that's how many bobblehead sections there are, and we are solving for S. So now all we're doing is solving an equation. So we just solve for S, and S equals 18. We use our cross products property to do that. So there are 18 sections on the wheel. Our last example looks scary, but it's not. So example 5, comparing experimental and theoretical probability. The bar graph shows the results of rolling a number cube 300 times. What is the experimental probability of rolling an odd number? So this means that somebody actually rolled that number cube 300 times. So we've got 48 ones, 53s, and 49 fives. So those are the experimental probability numbers. If you add those up, we rolled an odd number 147 times, and there were 300 rolls. So our experimental probability was 49%. How does the experimental probability compare with the theoretical probability of rolling an odd number? In section 10.2, example 2, you found that the theoretical probability of rolling an odd number is 50%. And you know that because there's 3 odd numbers on a number cube, and there are 6 total numbers. And that equals 1/2, which equals 50%. So it says compare the experimental probability in part A to the experimental probability in example 1. So as the number of trials increased from 50 to 300, the experimental probability decreased from 58% to 49%. So it became closer to the theoretical probability of 50%. So that's what happens. The more we do our trials, the closer we get to our theoretical probability. Remember, you're finished with this flipped lesson when you are prepared with your notes, your vocabulary, and all your other work. Also be prepared with any questions, and as always, have a great attitude.